Hey guys, welcome back. In this video, we're going to be learning about the trigonometric functions from Cambridge Additional Mathematics. So first, let's begin with a periodic function. A periodic function is defined as a function that repeats itself over and over in the horizontal direction in intervals of the same length. You can see this everywhere you go. So for instance, if you take a wheel, it always goes in this motion, which is a periodic function. I haven't drawn it properly, but these are supposed to be of same length and they're in the horizontal direction. This portion keeps repeating. So that's why it's a periodic function. And then the period of a periodic function is the length of one repetition or cycle. Okay, let's label this as 2, let this be 0, 4, 6, and so on. The period of this would be 2 units, whatever the units be. It's the length of one repetition or cycle. So that's what this means. And then f of x is a periodic function with period p. If that's the case, then f of p, x plus p is basically f of x. So that's what a periodic function is. Okay, now that you know the definition and we've looked at a few examples, try to solve this. Try to find which of these are periodic functions and which of them are not. I'll give you 2 minutes, pause the video, and then you can come back. I'm assuming that you've answered the question. The first one is a periodic function because this part keeps repeating over and over again. So this is a periodic function. This also is a periodic function because this part keeps repeating and it's of the same length. And then C is also a periodic function because if you look from 0 to 3, the same pattern can be noticed even here. So that's why this is a periodic function. This is not. As you can clearly tell by this, it's not a periodic function. And now what about E? Of course it is. And so is F. And G and H are not. So the answers were A, B, C, E, and F. So these were the periodic functions. And now let's move on to the sine function. We've already learned about the sine ratio, which is basically if there's a triangle and this is theta, sine theta would be opposite by hypotenuse. So that's what sine is, sine theta. So if we graph sine theta, this is what we get. I will tell you the features of a sine function. The maximum displacement from the equilibrium is called as the amplitude. This is the amplitude because from the baseline or the x-axis, this much is the displacement, which is the amplitude, and it's the maximum. And then this would also be considered as the amplitude. A would be equal to 1 because the value of y is 1. So the amplitude is 1. And the period would be 360 degrees. This is the time required to finish one complete cycle. And there are no vertical displacement. If there was a vertical displacement, it would look something like this. This is the graph of sine theta plus 0.5. I will show you some of my notes that I've taken down when I wrote my IGCSE exams. I haven't drawn the graph of sine x, which was my mistake, but you can see this. This is what a sine graph looks like. So let's look at the points. So sine x is a function as it passes the vertical test. In functions, we've learned about the vertical test and what a function is. So I'm not going to go over that again. If you want, you can go to my channel and check out the video. And then sine x is 0 when x is the even multiple of 90. For instance, 0, 90, 360, etc. Sine x, the value of y is 0 when x equals to 0, x equals to 180, and x equals to 360. So you have 3 points where the displacement from the equilibrium or the x-axis is 0. And then you have 2 maximum points. This is the feature of a sine function. And then sine x is either 1 or minus 1 when x is an odd multiple of 90. So an odd multiple of 90 would be 90 and 270. So at 90 degrees, there's a maximum. And at 270 degrees, there's a minimum. And then, as we've already looked at this point before, it's that the sine function is periodic function because it repeats itself over and over again. So you can keep drawing this sine function from here. It never really stops unless you do. And then the period of a periodic function is defined as the length of one repetition or cycle. And the period of the sine function, sine x, is 360 degrees. Or if you want to write it in terms of radians, it would be 2 pi. And then it repeats every 360 degrees and 2 pi radians. So that's why the period would be the following. And then we have this small note that sine 2x has a period of 180 degrees. Let me show you the graph of sine 2x. Let me clear this. If this is sine x, then it will look something similar, except it will be scrunched. So it may not make sense right now, but I'll just draw it for you, and then you'll understand. This is honestly a really bad graph, but please just try to understand instead of looking at the thing. Okay, so this is what sine 2x would look like. The period has reduced by a factor of 2. So it would be 360 divided by 2. So that would be the period. The amplitude remains the same at 1 and minus 1. If you multiply the value of x by a constant, the period would decrease by 1 by that value, which is a. So that's how you draw it. It would be 180 degrees. So that's how you change the period of a function, or like the sine function. Then the amplitude of a periodic function is defined as the distance between a maximum or a minimum point and the principal axis. So the maximum distance, the distance between the principal axis and the highest point. So it would remain 1. And now the basic sine function sine x has an amplitude of 1. Because sine 2x is multiplied by a constant, which is 1, the amplitude would be 1. If it were 2 sine 2x, then the graph would look something like this. Just imagine this is point, here's 2. It would look, and let me draw this in this color. It would look something like this. The period would remain the same. Now let's just say this is 2 sine x. This is the graph of 2 sine x. The amplitude is increased by a factor of 2, so it's doubled. The period remains the same. So yeah. And then here's the graph of a into sine x. This is what the graph of sine x looks like, and this is 2 sine x. So the graph of y equals to 2 sine x is a stretch of the graph of y equals to sine x. It has been stretched from the x-axis with a stretch factor of 2. And the amplitude of y equals to sine x is 2, and the period remains the same, which is 360 degrees. If you multiply sine x by a constant, it will be stretched by the same factor from the x-axis. So that's what a sine theta or sine x means. And then similarly, the graph of y equals to 4 sine x is a stretch of y equals to sine x from the x-axis with a stretch factor of 4. The amplitude will be 4 and the period will remain the same. Let's look at the next factor. If we have y equals to sine bx, we've already discussed this, that if you have bx, the period would be reduced by the same factor as 1 by that. This is the graph of y equals to sine x, and this is sine 2x. There are two more cycles that can be drawn in the same space as y equals to sine x. So the graph of y equals to sine 2x has been stretched from the x-axis with a factor of 1 by 2. The amplitude remains the same and the period would decrease by a factor of 2, which is 180. And then the graph of sine x, it would be stretched by a factor of 1 by 4 from the y-axis. And the amplitude would remain the same, but the period would decrease by a factor of 4. So 360 by 4 is 90 degrees, or it can also be written as pi by 2. So this would be the graph of y equals to sine 4x. Now let's look at the final factor that could affect the graph of sine x. So y equals to sine x plus c. It is a translation which is vertical. So if we have y equals to sine x and we have y equals to sine x plus 1, it would move vertically up by 1 unit. So the graph of y equals to sine x plus 1 is a translation of the graph of y equals to sine x, and it has been translated by the vector 0, 1. So this has been moved up by 1. And then the amplitude would remain the same and the period would also remain the same. And similarly, the graph of y equals to sine x minus 1 would be a translation downwards by 1 unit. So the vector would be 0, minus 1, and the period and the amplitude would remain the same. But the maximum and minimum points would change, but the amplitude remains the same. So this is the conclusion. If we have a sine bx plus c, then the amplitude would be a, the period would be 360 by b, and then it will have a vertical translation of 0, c. So that's what we have learned so far. This is the conclusion. It's really important. This is really important to know because sometimes you'll have to plot the graph in your exam. And now try to fill the table. If you've understood the concept, then this should be easy. Okay, if you're done, just unpause the video and I will work the answer with you. So the maximum, okay. So the first question is y equals to sine x. The maximum would be 1, the minimum would be minus 1. The period is 2 pi and amplitude is 1. And now let's look at the second one, which is y equals to sine x plus 3. So we know that the max of this would be 1. So 1 plus 3 is 4 and minus 1 plus 3 because the minimum value of sine x is minus 1. So minus 1 plus 3 would be 2. And the period would remain the same and amplitude would also remain the same. And now let's look at the next one. We have y equals to sine x minus 2. The maximum value of sine x is 1. So 1 minus 2 would be minus 1. And the minimum of this would be minus 1, which is minus 1 minus 2, so minus 3. Period would remain the same, amplitude same. Now we have this. This would be 1 plus c and minus 1 plus c. The period would remain the same and amplitude would also remain the same. Now let's look at the second question. They've written down the answer. The maximum and minimum would remain the same. The period would reduce by a factor of 2. Amplitude same. Same. 2 pi by 3. 1. This would be 1, 1, 4 pi because 2 pi by 1 by 2, which is 4 pi. And amplitude same. This would be 1, 1. This would be 2 pi by b. Amplitude 1. So that's our answer. Now let's look at the last question. This one. This deals with amplitude. So maximum is 2, minimum is minus 2. Period remains the same. Amplitude would be 2. Similarly, this would be 3 minus 3, 2 pi, 3. And then maximum would be 0.5 minus 0.5. And 0.5. This would be a minus a 2 pi and amplitude is a. So now we've filled the table.